Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 9.3, and here we will discuss it is about matrix operations. We studied addition, subtraction, scalar multiplication in the previous video, and here we will discuss matrix multiplication. Well, matrix multiplication means how to multiply two matrices by each other. And let us begin by the definition of matrix multiplication for 2 by 2 matrices. So you have 2 by 2 matrix A, 2 by 2 matrix B. How to multiply them? Well, pay attention that the product matrix also has the order 2 by 2. How do you get this element? This element, you multiply row 1 of the matrix A, row 1 of A, by column 1 of the matrix B. So A times E plus B times G. And then how do you get this element? You continue with the same row of A, the first row, but this time you multiply the first row of A by the second column of B. So A times F plus B times H. And when you multiply the second row of A by the first column of B, you get CE plus DG. And the second row of A by the second column of B, you get CF plus DH. So we multiply rows of A by columns of G. This is how we define the multiplication, matrix multiplication. So example, let us multiply these two matrices. Let us find A times B. So A times B means I will write A first and then write B and find their products. Okay. The first element here, I need to multiply the first row by the first column. So 2 times 3, 2 times 0, sorry, 2 times 0, that's 0, plus 3 times 5, that's 15. And now how to obtain this element? This element in the first row, second column. So multiply the first row by the second column. 2 times 1 is 2. 3 times 6 is 18. What about this element? Second row by the first column. 4 times 0 is 0. 7 times 5 is 35. And the last element, 4 times 1 is 4, plus 7 times 6 is 42. So the answer would be the product matrix would be 15, 20, 35, and 46. Do the same here. Let us find A times B. Multiply the first row by the first column. So 1 times 4 plus 3 times 1. 1 times 6 plus 3 times 0. 2 times 4 plus 5 times 1. 2 times 6 plus 5 times 0. So A times B would be 7, 6, 13, and 12. Now we can generalize the process. We can multiply M by N matrix by N times N by P matrix. Notice that the number of columns equals to the number of rows. So for the product of two matrices to be defined, the number of columns of the first matrix must equal the number of rows of the second matrix. So this is the first matrix, M by N. So this N should be equal to this N. Otherwise, the product of two matrices is not defined. So if this is a matrix A and this is a matrix B and this is the product, how to find this element in the ith row, jth column? You take the row number I in A, multiply by the column number j in B, you get the elements in the ith row, jth column of AB. So again, you can multiply m by n times n by p. These two must be equal. The order of AP would be m by p. This is the order of the product matrix. So here, let us find A, B first. So this is A times B. What is the order of A? How many rows? One row. How many columns? Three. What about B? How many rows? Three. How many columns? One. Is 3 equals to 3? Yes. So what would be the order of the product when you multiply these two matrices? It would be one by one. So it would be just one element. How to get it? Multiply 1 times 4 plus 2 times 5 plus 3 times 6. So the answer would be 14 plus 18, 32. And this is the product of these two matrices. Now what about B times A? Well, if we start by B times A, now this matrix is of order 3 by 1, and this matrix 1 by 3, and 1 equals to 1. So we can, the product is defined, multiplication is defined. What would be the product matrix? What is the order of the product matrix? It would be 3 by 3. So we will have a 3 by 3 matrix. How? We multiply row 1 by column 1. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Then 5 times 1, 5 times 2, 5 times 3. Then 6 times 1, 6 times 2, 6 times 3. So see the difference between A and B. So in general, AB is not equal to BA. Even they don't have the same order here. So please do this one. Find AB and find BA similarly to the previous example. Let us find each product. Let us see, this is a 2 by 2 matrix and 2 rows and 4 columns. So this is 2 by 4. So what would be, can I multiply? Yes. And here I will have 2 by 4, the order of the product matrix. So the first row by the first column, 4 times 1 is 4, plus 2 times 0. 4 times 2 is 8. Let me write it like this. 4 times 2 is 8 plus 2 times 2 plus 4. 4 times 3 is 12 plus 2 times negative 1 or just negative 2. 4 times 4 is 16. 2 times 6 is 12. So we finished from the first row. Now the second row, 1 times 1 plus 0. 1 times 2 plus 3 times 2. 1 times 3 minus 3. 1 times 4, 3 times 6. So the answer would be 4, 12, 10, 28, 1, 8, 0, 22. So this is the product matrix. Now here, what do we have? How many rows? 2. How many columns? 4. This is 2 by 2. 4 is not equal to 2. So multiplication is not defined. I cannot multiply this row by this column. This row has 4 numbers, this column has 2 numbers. Multiplication is not defined. Find the product. Do it, please. Similarly, check yourself now. And this is again not defined. This is properties of matrix multiplication. Notice that AB is not equal to BA. But the associative property is okay. If you have 3 matrices, you can multiply AB first and then multiply by C, or BC first and then multiply by A. So here, this is a discovery. Verify the properties. Let me verify number one for you. So I find AB first. So AB would be equal to what? Multiply A by B. 3, 2 multiplied by 1, 3. So 3 times 1 is 3, plus 2 times 3 is 6. Then 0 plus 4. Then negative 1 plus 1 is negative 1 plus 12. Then 0 plus 8. So when you multiply A times B, you get 9, 4, 11, and 8. Now, the left-hand side is AB times C. And C is 1, 2, negative 1, 1. So what would be the left-hand side? 9 minus 4. 18 plus 4. 11 minus 8. 22 plus 8. So this is the left-hand side of the first property. Now for the second hand side, for the right hand side, I need to find BC first. So BC, I need to multiply B times C. So 1 times 1 plus 0. 2 plus 0. 3 minus 2. And 6 plus 2. So this is BC. And now I need to multiply A times BC. And this is the right hand side. And you have to follow the order. So A first. You write A first because you know AB is not equal to BA. Times BC, and this is BC. Multiply. 3 plus 2, that's 5. 6, 3 times 2, 6, plus 16, 22. Negative 1 plus 4 is 3. Negative 2 plus 4 times 8 is 32. Negative 2 plus 32 is 30. So you notice that the left-hand side is equal to the right-hand side. So 1 is correct. Property 1 is correct. So when you have 3 matrices, you can find the product either using this method or this method. You can check all the other properties similarly. Find A, B, B, A. I leave this for you. This is easy. It should be easy for you now, practicing. Also here, AB times BA. Let me find AB here. I multiply this row by this column. Okay, so 1, you can do that by the calculator if you don't want. 1 minus 1 plus 4. Okay, the answer is 4. Then this, the first row by the second row. So 1 minus 2 minus 4. That's negative 5. Then the first row also by the last column, the third column. So negative 4 plus 12, and that's 8. Now the second row, 4 times 1 is 4, minus 1 plus 3, that's 6. Then 4 times 1 is 4, minus 2 minus 3, second row by the second column. Now second row by the third column, negative 4, because 0 minus 4 plus 9, that's 5. And now the third row by the first column would be 0. The third row by the second column, 2 plus 2 would be 4. And the third row by the third column, negative 6. So this is A times B. And please find B times A by yourself and make sure, check that if they are equal, you will find that they are not equal in general. Well, here, this is 3 by 2, and this is 2 by 3. Okay, so let me do for you B times A. B times A would be this matrix times this matrix. And this is 2 by 3, and this matrix is of order 3 by 2. So I will have 2 by 2 matrix. So multiply the first row by the first column. 2 times 4 plus 3 times 6 plus 4 times 3. The answer is 38. The first row by the second column, 2 times 2, 3 times 1, 4 times 5. You add all of these, you get 27. Now the second row times the first column, negative 1 times 4, negative 2 times 6, 0 times 3, negative 16. Now the second row times the second column, negative 1 times 2, negative 2 times 1, and 0 times 5, and that's negative 4. Please find AB by yourself. Also here, this matrix is 2 rows. How many columns? 4. Here I have 1, 2, 3, 4, 4 rows and 2 columns. So let us do here B times A. Okay. And I leave AB for you. This is B times A. Now this matrix order 4 by 2, this is 2 by 4. So what is the order of the product matrix? It would be 4 by 4. All right. 2 plus the first row times the first column. 2 plus 2, 4. First row, the second column. Negative 3 plus 2, negative 1. Then 1 minus 4 is negative 3. Then negative 1 plus 2 is 1. Negative 2, now the second row, multiply by all the columns. Negative 2 plus 1, 3 plus 1, negative 1 minus 2, 1 plus 1. Now the third row by all the columns. 2 times 5, 10 plus 4, negative 15 plus 4, 5 minus 8, negative 5 plus 4, and finally the last row. 10, 5 multiplied by all the columns. 20 plus 5, Negative 30 plus 5. 10 minus 10. Negative 10 plus 5. So this is the matrix BA, and I'm confident that you can find AB similarly. Well, here, find BC, multiply BC plus CB. Okay, do that, please. Find BC, then CB, then add them. Here, you need to find B plus C first, and then you multiply by A from the left. Okay, so let me do this one. Let us write A 40 negative 35 0 1. I will multiply this by B plus C. So let me add B plus C. 5 plus 1 6. 1 minus 1 is 0. Negative 2 minus 1 negative 3, and negative 2 plus 1 is negative 1. Now this is 2 3 by 2 matrix, and this is 2 by 2. So you will get 3 by 2 matrix. First row by all the columns, so 24 0. Second row, negative 18, negative 3 times 6, negative 18. 5 times negative 3, negative 15. So that's negative 33. 0 minus 5. 0. Now the third row, minus 3, and 0 minus 1. So this is the matrix A times B plus C. We did someone's similar. Find BC and then multiply by A. That's the end of this section. I hope you enjoyed matrix operations.